So today we're gonna discuss the optical activity and reaction mechanism. So by far we started organic chemistry. Let's give us like recall for the previous topics that we discussed. So we are doing the optical isomerism, starting with the organic chemistry portion. So we saw what are optical isomers, what are enantiomers, racemic mixtures, what is plane polarized light, what is a polarizer, what is a polarimeter, how it works, what are the components, all of those. So, do you have any confusion at any point?
No.
Okay, sounds good. Next, we have optical activity. So we know what is optical activity. Now we're gonna see how optical activity is actually implementing in different reaction mechanisms. Okay, reaction mechanism simply means the pathway, the route that a chemical reaction follows to convert the reactants into products. Of course, the reactants in a chemical reaction are like converting into products in a manner. For maybe the chemical reaction is a single step chemical reaction called as elementary reactions. I do not remember if I told this before or not, but the single step chemical reaction are called as elementary reaction, while the multi-step chemical reactions are also available, right?
Yeah, we did it.
Okay. So firstly, the first type of chemical reaction that we are seeing today is nucleophilic substitution reactions. Firstly, we should be very clear about what are nucleophiles and what are substitution reactions. So if we
Yeah.
look at the substitution reactions, the term is already like self-explanatory. Substitution simply means that you're replacing one part of the compound with some other group or some other component. So you're simply substituting it.
Yeah.
Then the second term is nucleophilic. So there are two common terms in chemistry: electrophiles and nucleophiles.
Yeah.
Nucleophile means electron-rich species, means they are nucleus-loving.
Yeah.
Okay, means they have like sufficient electron density. And if you're talking about electrophiles, these are electron deficient species. They have positive charge in them. Okay, they are generally written as nucleophile as this because the negative charge apparently tells us that they are electron rich, they are nucleus loving, and electrophiles are represented as E positive, which means that they are electron deficient. Okay, now you can totally come up with different examples. For example, Cl negative is a nucleophile. Hydroxyl is the most common example for nucleophile used in different chemical reactions.
Yeah.
Okay, and all of the anionic species or the species that are like deficient in electron density, they are classified as electrophiles. For example, can you call for some example of electrophiles?
Any cation really.
Yeah, any cation. For example, an electrophilic carbon having three bonds. You can see that there is some deficiency of electron. Carbon usually has like
Yeah, 4 bonds.
carbon is tetravalent and it usually has like four covalent bonds. So in this case, you can see that there is some deficiency of electron in the central carbon atom. Means it is electrophilic now, and
Yeah.
all of the kinds they also fall under the category of electrophiles.